Hi, my name is Visal Sri Lakshmi Devalla. Now I am going to discuss about the Wolf-Kishner reduction. In this Wolf-Kishner reduction, carbonyl compounds are converted into alkanes in the presence of hydrogen and a base like NaOH or KOH. That means in this reaction, carbonyl compounds means the compounds which are having C double bond O are known as carbonyl compounds. Especially aldehydes, ketones or comes under carbonyl compounds, and other compounds having C double bond O group or acids or acid derivatives, esters, ketones, some other compounds also there. But in this Wolf-Kishner reduction, carbonyl compounds of aldehydes and mostly ketones are converted into alkanes. This happened in the presence of hydrogen NH2, NH2 and in the presence of base. So this hydrogen is especially used to convert the carbonyl compounds into its hydrogens. Then it is easy to convert that hydrogen into an alkane using a base. So this is the Wolf-Kishner reduction is an effective tool in organic synthesis, and it is mostly useful in the preparation of pharmaceutical compounds. In this reaction, the double bond of carbon and oxygen is changed to a methylene group. In this process, the C double bond O group is converted into a methylene group, CH2 group. Simple hydrogens are formed by condensing hydrogen. So this hydrogen is condensing with this carbonyl compound we have taken. Hydrogen with aldehydes and ketones, which decompose at high temperatures, releasing nitrogen gas. So at that high temperatures they are releasing some nitrogen gas. Sorry, not hydrogen. Here nitrogen gas is released in this reaction. Here see, this is the mechanism of Wolf-Kishner reduction. In this this is the step 1. In this step 1 there is an addition of hydrogen to carbonyl compound. So here, as it is a highly electronegative element oxygen, it is polarized towards this highly electronegative oxygen atom, and it is forming a negative charge on it, and to this positively charged carbon this lone pair is attracted and it is forming a bond with nitrogen. So in the second step, proton transfer. So this proton is transferred towards this negative charge, and these bonded electrons are polarized towards this nitrogen to neutralize this positive charge. Next, now nitrogen is having lone pair of electrons as it is having 3 bonds around it. So these lone pair of electrons are attracted towards this bond, and it is forming a positive charge. So to neutralize that positive charge, these electrons are polarized towards the nitrogen atom, and these electrons are polarized towards the oxygen. So then it is forming a double bond between the positively charged carbon and a negatively charged nitrogen. Then it is having 4 bonds around, then it is having a positive charge. Now to neutralize this positive charge, these bond pair of electrons are attracted towards this nitrogen and forming this compound. So in this step, deprotonation means one proton is removed from this compound, and this is the another step. In this step, due to the presence of base, one proton is removed from this anhydride group. Then immediately here these two electrons are polarized toward this nitrogen, and this double bond pair of electrons are polarized toward this carbon atom. And see this in this part, so these are polarized toward this nitrogen. And another step, again in the presence of base, as before, one proton is removed from this nitrogen and it is forming this negative charge. Next, in this hydrolysis reaction, this negatively charged carbon is attracting proton from this water molecule and it is forming an alkane. Next, see the applications. So before going to see the applications, see the mechanism again. Here the step 1 is addition of hydrogen to carbonyl group. So for this, only the carbonyl group present in the compound is affected in this Wolf-Kishner reduction. So then it is forming hydrogen combined carbonyl compound. Here in the second step, proton transfer. Here proton is transferred. See